director of HIEE. We started HIEE in the year of 2010 with the intent of upskilling engineering grads by means of providing industrial knowledge. We started with 3 engineers in the year of 2010, and in these 12 years of journey, we trained almost 12,000 plus students, and out of 12,000, I can proudly say 8,000 plus engineering grads got placement, starting from small scale industries to the top MNCs. By keeping the world-class needs in mind, we have designed our classroom as a virtual classroom, and which is suitable to conduct the classes online and offline segment.
In HIEE, what we do is we take one-on-one sessions where we give them a tailored program where they can work and clear the interview at least in first 3 attempts.
If I have any doubts to clarify, the team of HIEE is available at any time to clarify any doubts for me.
HIEE plays a very important role. It does this quintessential job of transforming students who come with raw knowledge of engineering, whether it is electrical, civil or mechanical, and convert them into a finished ornament. A finished ornament in the sense that the engineering company is ready to accept them as an employee in their organization.
In addition, with our technical classroom training, we are providing industrial visits, we are going to outdoor solar PV plants and substations and switchgear panel visits, and based on the permissions we are getting, we will also visit various power plants. Coming to the civil people, we will visit various construction sites.
We try to understand every person's or an engineer's abilities and then work on their efficiencies and to the core segments and help them to get placed in a right career in all aspects.
I used to work in residential field as a technical supervisor in maintenance department. I worked 3 years in maintenance. Then I decided to upgrade my knowledge in the core. Then I got to know about the HIEE doing great job for the engineers who wants to settle in the core. I trained from the HIEE and good knowledge in core. I got placement in Accutronic India Private Limited as a service engineer. I am very happy with my role and company thanks to HIEE.
We conduct various mock interviews during the training. Based on the company profile, we separately train the candidates on interview segment, what kind of questions they may ask you during the interview, and so that will help them in boosting their candidates' confidence. That's how HIEE students are excelling in the interviews.
At HIEE, we were given personal assistance, and every week mock interviews were conducted, and which helped me in cracking interviews at a very early stage, and I'm very happy with HIEE.
Thank you to HIEE for getting me that opportunity.
I'm very much glad that HIEE is celebrating its 12th anniversary. I wish many more to come. Thank you, HIEE.
HIEE is the one-stop solution for the engineering grads to get your dream jobs and to upskill your knowledge. Join with HIEE, get skilled, get hired.
Hi guys, hope everybody is able to hear us. Can you all hear me? Can I get a yes in chat box, please? All the people on available here. You can tell your friends who are not able to join onto the respective meeting. They can connect through us on YouTube, and we will be addressing them. Guys, can you all hear me? Please, I request everybody who's attending the session to check your internet connectivity. There could be a problem from your side also, if in case you're not able to hear us properly. Please make sure that you're all l- able to hear us. Sanket, can you please check your network, and can you please increase your volume to make it audible, because I get it is audible from everybody else also. Yes, thank you. Thank you. That's a great response. People who are unable to connect through the Zoom meeting in live, you can attend or you can view the session on YouTube live, where you can see it from there. And our team is available to address your queries on the YouTube also. Thank you. Thank you. So once again, welcome to HIW guys. I am Bhavya. Hope everybody is able to hear me, and then yes, hope everybody is able to see me. Right. So welcome to HIW webinars, guys. For the people who don't know us, we have been established 15 years ago, HIW, as in HIW Empowering Engineers Private Limited. That has been the forefront for the equipment engineers with the skills, knowledge, and the confidence to excel in their careers. As in premier finishing school for engineers, HIW bridges the gap between the industry and academia, offering on hands-on training, real-world insights, and tailored programs, which are designed to prepare them as in professionals to make sure that they excel in their industries. Making an For this, if you look into it, today we are marking an exciting new chapter into its journey. HIW is proud to launch its inaugural VLSI Masterclass. The initiative reflects the institute's top-notch faculty, industrial partnerships, and a curriculum designed for both beginners as well as the experienced engineers. The masterclass sets a new benchmark in its specialized engineering education, guys, with a legacy of empowering thousands of engineers in the past years. And we are a future focused innovation with respect to our transformative learning experience. We welcome our speaker today, Mr. Pruthwiraj, who holds a master degree on VLSI from NIT Delhi and currently serving as an senior design verification engineer. In this role, he is responsible for FPGA verification for Intel Penang, Malaysia. Over the course of his career, he has worked with leading clients, including Intel, AMD, XMT Semiconductors, Star 5, and Sequence. Additionally, he has also published many papers on IEEE conferences. Hi, Prithvi, can you please unmute yourself?
Yeah, yeah.
Uh,
Hi, Bhavya. Hello,
hi.
all.
Yes, I'll just add you on to the spotlight. Yes, hope everybody is able to. Is Prithvi's voice audible, guys? Right, thank you. Prithvi, you can take over.
Yeah, yeah, sure. Thanks, Bhavya. Yeah, hello, all. Good evening. Hope everyone is doing well. Okay, just give me a moment. Let me share the screen. Yeah, okay. Okay, so just a moment, please. Yeah, okay. So, uh, welcome to everyone on Silicon Symphony. Here we'll be having a 5 day session on insights into VLSI, like what is VLSI or how to get into VLSI industry, and what are the course of actions that we have to take if at all we want to be a good engineer in VLSI industry, and what are the career options in VLSI industry. All these things we'll be going to know in this session and no, my name is Pruthwiraj, and as Bhavya told, I hold a master's degree from NIT Delhi, and I work as a senior design verification engineer. And in my career, I have worked for various clients Intel. Yeah, I have worked for various clients like Intel and AMD, as well as Starfy, Sequence Communications. So there are many clients I have worked on, and my expertise includes I have worked on IP level, subsystem level, SOC level, as well as I have worked at full chip level also. So I have worked at several levels, and my expertise include working on I2C as well as I3C protocols, and then I have worked on PCIe. I have worked on PCIe for almost 2+ years for Intel. So this is about brief about me, and so let us deep dive into our core discussion of today's session. So what is VLSI all about? Generally, in general sense, like what is VLSI all about? Okay. So see, for example, let us take an example of, for example, you all might have gone to a mall. Yeah, there, in order to have a count, the security guard or whosoever standing over there near the gate, they will be holding something and pressing a button, right? Something like this, tick tick tick. So it will be counting like how many people are inside, right? So what is that? That's a manual counter, right? Whatever the thing that they are holding is a manual counter, correct? So, okay, what does the manual counter will be having? It is a mechanical thing. Yeah, whatever the thing that we are seeing is a mechanical thing which is used to count. Means the moment you trigger it or press it, count will increase. Eventually, you will know. It's a simple design. Yeah, even everyone. By having a small expertise into that, anyone can design it, this. But what is the problem with this? It is simple yet problematic. What is the problem? For example, if I want past 10 days of data, how many people visited the mall in last 10 days, can I get it through it? That's quite difficult, right? We cannot get. Or for example, let us analyze, I want to analyze like over past 1 year, over the past 1 year of time, I just want to know at which time people are more, more people are coming into the mall, at which time people are coming into the mall, and on which day, of of the month or of the week people are more, and on which day people are less. So when on the day on which people are less, I can do some necessary precautions, or I can keep some offers on that particular day so that I can attract more people to my mall. So it means that I want to do some statistical data. I want some statistical data. Can I get that by using this mechanical counter? It is quite impossible, right? But it is a simple design. It is a simple design, but it is not possible to have some statistics for us. Then what is the solution for this? We just need to automate it. What do I mean by automation? It means that we just need to have a counter. It's a simple thing, right? We just need to have a electronic counter. The moment I say counter, what comes to your mind? Yeah, the moment I say counter, what comes to your mind? As far as your digital electronics is considered, what flip-flop should come into your mind, right? Flip-flop is something which can count, yeah, which has some mod number and some other things, and it can count. But the moment I talk about flip-flop, what is there inside the flip-flop? What is there inside the flip-flop? Yeah, basic gates, right? Flip-flop will be consisting of all basic gates, right? It is having all basic gates. For example, if I take an example of a half adder, okay, if it is a half adder, what does a half adder contain? Half adder will be consisting of a XOR gate and a AND gate, some simple design like this. Yes. So if I want to prepare something like this, or if I want to prepare a counter, okay, if I want to prepare a counter which can count like how many number of people are inside, or on which date they are, if I want to have some statistical data, so I need to design a counter, a flip-flop based counter. For that, what I have to do? I have to program the gates. I have to design something with gates. Okay, it means that you went to the market and purchased some gates. But what is inside a gate? Again, see, initially we said flip-flop. But what is inside a flip-flop? A gate. But again, what is inside a gate? For example, I'm talking about an AND gate. What is inside an AND gate? Yeah, basically it's our MOS transistor, right? This is our CMOS transistor. It will be an MOS inverter pair. Something like this. Yeah. So AND gate will be consisting of such MOS transistor pairs. Correct. So then what I'll do? For example, let us assume I want to design something known as full adder. Okay. I want to design something known as full adder. Then what I have to do? Or let us assume all of you know about a calculator, right? I want to design a calculator or a full adder. I means I want to make a chip out of it. Okay, I want to design a chip. Okay, I want to design a chip which can perform addition of two numbers, or I want to design a chip which can do the calibrations. Like, we have our scientific calculator, right? That kind of chip I want to make out of it. How can I make that? It's quite simple. Like, we have to what? For example, for ease of understanding, let us go to full adder. Full adder consists of what? Three input XOR gate and some basic AND gate, some three input AND gate or whatsoever. So it will be having a sum and carry. So what I have to do? I have to prepare its equivalent XOR gate, right? And I have to prepare its equivalent AND gate by using MOS transistors. And then what I will do? I need to fabricate this. Okay. So after the fabrication, what I could see is a basic IC. Okay. What I could see is a basic IC which can perform addition of two numbers. Like, assume that A is one input, B is other input, and S and C are its outputs. So it's a basic MOS transistor. But what is the difficulty with it? As of now, we are not seeing any difficulties, right? As of now, there is no any difficulty in this. So let me take this discussion a little forward. Like, give me a moment. Yeah. So yeah. So for example, I have fabricated it. Okay, I have fabricated it. Now my IC looks something like this. Okay, which has some two inputs and two outputs. Okay, this is a full adder. Now what I have done is I have given a number 5 here and I have given number 3 here, and it's adder, right? So what is the output expected? Sum should be 8, right? 5 plus 3, it has to give sum as 8, but something happened. Something happened and it is giving a result as 7. What could be the reason? What could be the reason? It means that there is a bug in the design, right? It means that there is a bug in the design. So what we might have done before fabricating the chip? We should have verified the chip, right? Even before fabricating, we should have verified the chip. So let us come back to our initial point of discussion. Like, 5 is the input, 3 is the other input, and which is supposed to produce 8 as the correct output. But what it is giving? It is giving 7. It means that what? There is a bug. A bug can be of two types here. Okay, here bug can be of two types. Either it can be a functional bug or it can be a fabrication bug. Okay, it can be either a functional bug or a fabrication bug. Just a moment, please. Yeah. So it can be a functional bug or a fabrication bug. For example, the moment I say fabrication bug, recently, Intel has a bug in its. Okay. Like, it has a floating point bug. That bug is basically due to fabrication. Like, this particular bug is seen in our Intel i3 and i13 and i14 generation processors. It is a fabrication bug. Or even there is one functional bug also in earlier versions of the Intel, that was in, I think, I guess it is a Pentium processor. Okay, it was a Pentium processor which has this bug. So bugs can be of two types in VLSI. Either it can be a functional bug or it can be a fabrication bug. Okay, so it means that what could be the reason for getting 7 as an output instead of 8? It means that there is a bug. Correct. So now, let us see, if it is a full adder, it has two inputs A, B. So what are its possible combination of inputs? 0, 0, 0, 1, 1, 0, 1, 1. And what is the output of sum? It can be 0, 1, 1, and it is 0 with a carry of 1. So as it is a 1-bit thing, we are doing it. Okay. What if my input is 2-bit? What if my A and B are 2-bit? It means that what are the different possible combinations for A and B? A can, yeah, it is of 2-bit now, 1 down to 0. it is 2-bit. It means that it can have 0, 1, 2, 3 as its inputs. Even value B can have 0, 1, 2, 3. So what are the possible combinations? 0 plus 0, 0 plus 1, 0 plus 2, 0 plus 3. Or 1 plus 0, 1 plus 1, 1 plus 2, 1 plus 3. Like, 3 plus 0, 3 plus 1, 3 plus 2, 3 plus 3. Means totally there are 16 possible combinations. So it means that even before fabricating this chip, what we have to do? We have to verify it, right? So as there are only 16 combinations, we can manually verify it before sending it to fabrication or before fabricating it. But what if my adder is having some inputs like, if it is a 64-bit input, if it is a 64-bit input, how many different combinations are possible? They are quite huge. See, if it is a 2-bit input, how many different combinations? 2 power 2 into 2 power 2, totally 16 combinations. Similarly, if it is a 64-bit, it is 2 power 64 into 2 power 64. Wide variety of combinations we are getting, right? So it is manually quite impossible for us to verify, right? It is manually quite impossible for us to verify. That is where we need some computational tools. Okay, that is where we need some computational tools in order to do some computation. Okay, the moment I said computation, there exists a problem. What is it? See, for example, okay, so far what we have done, I have designed one circuitry, okay, and I want to verify its functionality. Correct, but I don't want to do its verification manually. I want to use some computations in between. I want to use some computational tools. The moment I say computational tools, I mean computer is coming into the picture or processor is coming into the picture. So does your processor understands these things directly? I say like, there is an XOR gate, there is an AND gate, and I want to do some kind of processing with it. So can we tell this to our processor directly? No, it's not possible. Why it's not possible? Because our computer or our computational tools will only understand binary, right? They will only understand binary. It means that they can understand either 0 or 1. They cannot understand anything apart from 0 or 1. It means that I have to tell to my computational tool in order to verify it. How? Computationally means I have to inform it in form of zeros and ones only. How can I do that? I can do that by using any one language, right? It means that here there is a hardware. I have to describe this hardware by using a language. Yeah, I have a hardware and I have to describe this hardware by using that language, and I can give instructions through this language to the computational tool. Thereby this computational tool can do some processing of the data that we have given. So what is that intermediate guy that is required here? The thing that we need is a HDL. HDL stands for hardware description language. So what is the significance of this HDL? What is the practical significance of this HDL? See, as we are humans, we can see that this is a adder. Okay, it is a 2-bit adder or 3-bit adder. How many number of different combinations it requires, all those things we can verify manually. But the moment I say it is a 64-bit input, the very manual verification becomes quite difficult, right? Or for example, let us assume that Intel is designing its microprocessor. Assume that Intel is designing its i15 microprocessor, 15th generation microprocessor. Can you verify it manually? Quite impossible, because the floating point precision it is going to have is quite huge. So it is quite difficult. Manual verification is quite difficult. So what we need to do? We need to tell the tool that this is the hardware that I am going to have, and you have to tell that by describing the hardware. So in between that, you should use a language. What kind of language? That is the HDL language. HDL stands for what? It stands for hardware description language. So here I am describing my hardware by using a language, and I am calling it as what? HDL. Okay, so there are two kinds of HDLs into the industry. One is VHDL, other one is Verilog. Okay, one is VHDL, other one is what? Verilog. Okay, once I have written code by using these things. Okay, I have described my hardware, like, for full adder, I will be telling my tool that I need one XOR gate, I need one AND gate, I need one OR gate. All these things I will be telling. I will be writing a code that I want to have such a kind of hardware by using any one of these languages like VHDL or Verilog. Once I am done with the coding, then what I have to do? I have to feed this data to my tool so that my tool, by using the tool, I can verify its functionality. Okay, I can verify its functionality. Once I feel that the verification is successful, okay, once if I feel that the verification is successful, then what can I do? I can send it to the fabrication, right? Once I feel that all the possible combinations have been tested and the results are satisfied, then I can send it to fabrication. So in this case, is there any chance of getting a bug? No, because previously what did we do? Previously what did we do? We have simply taken our mass transistors, fabricated them and sent them to the market. So as a result, what happened? If I give 5 and 3 as input, instead of getting 8 as output, what I got? I got 7 as output. It happened because I did not verify my design, basically. So that is the reason. At the next step, what did I do? I have verified my design. Okay, using what? Initially, in order to verify, I have described my hardware using HDL language and then I have verified it. After verification, I am sending it to the fabrication. Now there will not be any difficulty, that there are very less chances that there could be a bug detected. Okay. Now, so if we see all these things, okay, so just okay. Fine. So see here, I can divide this into two things here. Okay. So whatever the thing that I have done here, what did I do? I have written a code by using one HDL language in which I have described the hardware, like what is the hardware I need. And then what did I do? After coding, what did I do? I have verified the design. I have verified the design. Once the design is verified, what did I do? I have sent it to the fabrication. So here it can be divided into two things, like, before the fabrication, whatever the thing we have done is known as front end design. Okay, whatever the thing we have done here, it is known as front end design, and whatever the thing that we are going to do after the verification is known as back end design. Okay, it means that VLSI design or VLSI flow is having two things. One is the front end, other one is the back end. So what are we doing in front end? In front end, we simply describe our hardware using a language and we will verify our design. That is done. After that, what are we going to do? We are going to do the fabrication of this. The fabrication of this is nothing but a back-end design. In back-end design, there are many steps involved in both front-end and back-end. For example, in back-end, a thing comes into the picture is PD. PD stands for physical design. Here, many other things will be coming into the picture in case of PD. Okay. And so if I assume, like, the time to market is, let us assume the time to market is 2 years. So among these 2 years, 70% of the time, not more than 70% of the time is taken by the front end, and 30% of the time will be consumed by the back end design. And even in this 70% of the time, more than 60% of the time is exclusively consumed by verification guys. Okay, more than 60% of the time is consumed by verification guys. The guys who are working at this level are known as DV engineers. Okay, DV stands for design verification. Means here we are verifying something which is designed, and this DV is quite crucial in the life cycle of the VLSI industry, because this is the one which is consuming huge amount of time. More than 60% of the time is being spent here in DV. Okay, and if anything goes wrong here, it will impact the design. Overall design will be impacted, because if something goes wrong and a defective product came out, if at all you want to refabricate it, again the time to market is 2 years. In between that time, what happens? For example, Intel has prepared one faulty chip. Then what happens? AMD will take over Intel. AMD आके Intel को कहा जाएगा, or Nvidia will be coming into the picture, and they will be taking over the Intel. So these kind of difficulties will be there if at all verification is not done properly. And India is quite famous for DV guys. And in India, many of the openings are with respect to design verification. And the moment I say about design verification, okay, you should be familiar with few languages. And also the moment I say about HDLs, okay, how many HDLs do we have? As we have discussed just before, it can be VHDL as well as Verilog. Okay, so VHDL is a pretty old language, and Verilog is the advanced version of the VHDL. Okay, and as VHDL is having few bottlenecks in it, like it is quite verbose, and typecasting is not permitted, so lot of difficulties, and it has complex data types into it. So all these things are reduced. All these bottlenecks were addressed, and a new language came into the picture, that is Verilog. So Verilog is quite widely used in HDL design. Apart from Verilog, enhanced version of the Verilog is System Verilog. So this System Verilog and UVM is a methodology which stands for Universal Verification Methodology. SV stands for System Verilog. So these things will be used while verifying our design. Okay. So any VLSI design will be consisting of two ends. One is front end, other one is a back end. And front end is the one which is consuming most of the time. In that, verification is the one that is going to consume huge time. Okay. So see here, as I told you, 70% of the time will be for verification, and 30% of the time will be for fabrication. Okay. So what are the different roles a VLSI engineer is offered? Okay, what are the different roles you will be offered? If it is front, I mean, obviously there can be two things. One is the front end guy, other one is the back end guy. Okay, so what are the things that will be there in the front end design? As per your understanding so far, can you guess on anything? Like what could be the different roles a guy can be working on if it is VLSI industry? Can you guess or type in the chat box? On whatsoever the discussion we had so far, can you guys get like what could be the different roles? Yeah. Okay. RTL engineer, physical design engineer, quality check, DV, design verification. Okay, great response. Thank you. So see here, there can be design engineer. Okay, there can be design engineer who is basically responsible for writing the code of the design. Okay, he will be doing this by using any one of these RTL languages, like I mean RTL is nothing but here HDL. Okay, one is the design engineer. What is the other role? Is the design alone sufficient? No. If something is designed, there could be a bug in the design. So there it requires one more guy to verify whether the design is correct or not. So who else is required? A verification guy is required in order to verify its functionality. For every design engineer, it is approximated that at least 3 verification engineers are there. Verification engineers are required. Okay, the ratio is 1:3. Once you have verified the design, then what else? Then we need a DFT engineer. DFT stands for anyone? Design for testability. DFT stands for design for testability. We need DFT engineer. After DFT, what we need is a STA engineer. STA stands for static timing analysis. For example, assume that I have given an input at some 1 nanosecond, and I have to get the output at 1.01 nanoseconds. If I give the input at 1 nanosecond and I'm getting the output after some 100 nanoseconds, is the design a correct design? No. It means that its timing needs to be verified. So we need one more guy who will take care of that, and he is known as STA engineer. STA stands for static timing analysis. Okay, static timing analysis. This is where all your clock skew, clock jitter, setup time, hold time, all these things will be coming into the picture here if it is STA engineer. And then we need a PD guy. PD stands for physical design. Okay, physical design engineer. What does this physical design guy will do? I mean, here by physical design, I mean that he should be having an extensive knowledge on CMOS. Okay, you should be having a good or quite extensive knowledge on CMOS. Once the physical design is done, or in physical design, what we will be doing is we will be doing something known as layout and many other fabrication things. We will be discussing all these things in our due course of time, probably tomorrow. Okay, as of now, we just go with the notion. Okay, so physical design. Once physical design is done and everything is verified at this level, then what we will be doing? We have to fabricate our chip. Yeah, we have to fabricate our chip. It means that there should be a fabrication guys. There should be guys who are working at fabrication level. Okay, so basically the roles offered are broadly into divided into two things. Like one is the front end engineer, other one is the back end engineer. Okay, who one is the back end engineer. So which field should you choose? Whether should you become a front end engineer or a back end engineer? Yeah, whether should you be a front end engineer or a back end engineer? How will you choose? Based on what you will choose? So based on your understanding, can you tell me where is the coding, extensive coding is involved, in front end or back end? Where is the extensive coding involved? Yes, it is front end, right? It is front end. Front end is the one where you have to write your code. That is the HDL. You need to describe your hardware, like these many AND gates I want, these many OR gates I want, this is the logic I want to implement, this is the functionality I want, this is the core logic. So all these things we are going to tell to the processor. Okay, depending upon what? By using a language which is HDL, hardware described language. So extensive coding or the RTL coding is involved in front end or back end? It is involved in front end. So if you are a guy who are good in coding, who are good at analytical ability, then you can choose the front end design. And if you are a guy who is good at analog side, like you are good at designing of op amps, designing of differential amplifiers, and you have very good extensive knowledge on CMOS and or all the characteristics of your CMOS inverter and its parasitic capacitance, parasitic impedance, or if at all you are good at all these things, and you are not like you are not a coding guy, but you like analog, then the career path for you is physical design. And believe me, physical design is quite difficult compared with front end design. Physical design is somewhat difficult. It is not that it is completely difficult, but it is somewhat difficult. Physical design is somewhat difficult. So this is how you have to choose your career path in VLSI, whether you want to be a front end engineer or you want to be a back end guy. Okay, fine. And so like who can become, or why VLSI is in demand? Well, nowadays we are seeing, right, VLSI, and people are paid huge in VLSI industry. If at all you are having around 10 plus years of experience, what is the package expected? Can anyone guess like what could be the package of a VLSI guy who is having 10 plus years of experience? Yes, anyone? Yeah, it is 1 crore actually. It is 1 crore. It will be more than 1 crore. Okay, if at all you are directly placed into any one of the core companies like Google, Intel, Nvidia, Samsung, or Marvel Semiconductors, your package is more than 1 crore. Okay, but why people are paying such a huge salaries to VLSI guys? What is the reason behind? Huh? See, same thing if we go into software or IT professionals, if they are having 10 plus years of experience, hardly if he's quite good and he is into core company, so he might be getting something around 50 lakhs to 60 lakhs. It is quite optimistic figure. But if it is VLSI industry, if you are having 10 plus years of experience, 1 crore is, just like that you can get. It's not a difficult thing to be achieved. Why VLSI is into such huge demand? The answer is, see, if it is IT job, okay, if it is IT job, what you will be doing? We will purely be working on coding, right? It means that you should be good at coding. You should know how a for loop works. You should know what are the data types of a language, what is a language constructs. So if you know that, you can write a code. That's not a difficulty. It is difficult to some people, I accept. But if it is VLSI, is coding alone enough? Is coding alone enough? Here, we should be having the knowledge of both hardware as well as software. Let me explain how. See, for example, I have a hardware here and I have software here. So more than 80 to 90% of the people, more than 80 to 90% of the people, they are either proficient in hardware but not proficient in software. Either they are proficient in hardware or either they are proficient in software but not proficient in hardware. So it is difficult to find a guy who is proficient in both hardware and software. And like that, there are only 10% guys. They are VLSI guys. Okay, just before we have seen, if at all you want to design a full ladder, coding alone won't help you. Coding alone won't help you. You should know what is its required hardware. Like, how many XOR gates are there, how many AND gates are there, how many OR gates are there, and you have to analyze them, and you have to write a code for them. The code can be written by using what? A language. What kind of language? A HDL. HDL stands for what? Hardware description language. Here you are describing the hardware. Even though you are good at coding, even though you are good at using software, that is not enough for you. Should have something else. What is that? That is hardware. Okay, it means that VLSI professional should be having two things into his mind. One is the hardware, other one is also the software. Okay, you should also be having extensive knowledge on software as well as hardware. So it is difficult to find a guy who is having these two things, who is going hand in hand with these two things. So that is the reason VLSI is into huge demand. Okay, and that is the reason people are less and they are paid quite huge salaries. Okay, so if we talk more into the design, profiles that were offered to a VLSI guy, VLSI guy can be a RTL designer. Okay, he can be a RTL designer, or he can even be a FPGA designer. We will discuss on what is this RTL design, what is this FPGA design, what are all these things in our coming sessions. Okay, and then he can be a verification guy, or he can be a he can be a DV guy. DV nothing but design verification guy. And on the back end, he can be a PD guy, physical design engineer, or he can be a synthesis engineer. I will tell you on what is synthesis. Okay, we will discuss that. Or he can be a STA engineer. And once the device is manufactured, okay, you have manufactured the device. Okay, after the fabrication, device is manufactured, but there could be a possibility that there could be some fabrication errors, right? There could be errors during the fabrication. Like I have told recently the i13 or i14th generation of the Intel processor is having some fabrication errors. Some oxidation thing happened in a channel. So while someone starts to use the CPU extensively, or if you start using high-end games, then due to the oxidation, what is happening is the channel is demanding more power. As a result, the processor is getting crashed. Okay, so there could be fabricational level bugs also. So what was the solution provided for that particular issue by Intel is they have released a patch update. Okay, they have released one firmware patch update, because of which the issue is fixed in most of the devices. So it means that what is the other role that could be offered in physical backend? There could be a post-silicon validation engineer. Okay, means on silicon you have fabricated your device. Okay, there is a silicon. On the silicon you have fabricated how many number of cores you want, or what is the thing that you want. You have fabricated it. Your chip is ready to be chipped. Ready to market. But can you send it like that directly? No. Even after the fabrication, you need to do some verification to this, right? So there is other post exists, that is post silicon validation. Okay, these are few broad things that you are offered if at all you are entering into VLS industry. Actually, there are many more columns or clauses of different engineers, but as a whole, this is how I can tell you in a understandable format. Okay, fine. And there are few misconceptions with respect to VLSI. Like what? People used to say, like, nowadays new thing came into picture, that is artificial intelligence and machine learning, because of which many software guys are losing their jobs. Same thing is going to happen with respect to VLS industry. It is 100% wrong. Not 100, it is 101% wrong. Why? Because see, the moment you're talking about AML, see, this AML can't run on its own, right? It needs to be run on a chip. Who are the guy going to make this chip? We the VLSI engineers who has to make these chips, okay? AI chips, artificial intelligence chips. NVIDIA is quite famous for making AI/ML chips. They are coming with extensive chips with extensive technology. It means that the more the technological advancements happening with respect to AI/ML, more is the demand for AI/ML chips. More is the demand for the chips. More is the requirement for the manpower, right? It means that you are given a huge opportunities with respect to the VLSI industry. Oh, okay. So if it is a software industry, it is not immune to the automation. Software industry can be automated, and you could already see people losing jobs. But same thing cannot be happening in the VLS industry. VLS industry is quite immune to automation. Means even in VLS industry, it has a scope of automation, but that automation will not result in cutting off jobs. In fact, indeed, it will result in more jobs. It will create more jobs. The moment demand increases for automation, people require industry requires more people. Okay. And tomorrow, I mean, on WhatsApp, however we have discussed, so we will be having like it's in detailed description on what is its practical significance in today's real life world, and what are the different technologies that were existed, how VLSI came into existence, and we will have some detailed description of design life cycle of VLSI in our next session. Okay. So this is all for today. If you have any doubts, we are open to it.
Thanks, Prithvi.
Yeah.
Yes, we have a question. What kind of basic coding language is required to be a VLSI front-end engineer?
Yeah, that's what we have discussed, right? It should be Verilog. Okay, it should the basic is Verilog, yeah. But Verilog alone is not enough, because if at all you want to be a design engineer, you should have its equivalent hardware. The moment I say I talk about hardware, what kind of hardware you will be learning? You will be learning digital electronics. Okay, you will be learning digital electronics. So this is I mean, Verilog is the language that is required for you. Apart from this, you need one more language, that is the enhanced version of Verilog is System Verilog. Okay.
How should I enter into this field?
Okay,
You can
you
get the
mean to say the
training.
yeah, that's it, to get the training and get into the industry. Or maybe one common question is like, I don't want to take any training, I still want to be placed. You can. So for that, what is the roadmap? Yeah, if that is the question, see, basically you should be good at analytical ability. First thing that requires to be a VLSI guy is you should have excellent analytical abilities. So even if you go to an interview, what they will see is not whether you're giving the correct answer or not. What they will see is what is your approach to the question. Okay, how are you approaching to your question is what they are going to see, but not your whether the answer that you're given is correct or wrong. And if at all you don't want to take training, still get placed, it is possible that you should be familiar with your these things like digital electronics, Verilog, System Verilog, UVM, and should have done a few projects. Okay, then you can do this.
Okay, Prithvi, before you answer the next set of questions, there are many questions regarding entering into the segment and how to learn VLSI. Guys, HIEE is starting a new batch on Jan 20th, 2025, and you can join our course. It is for 6 months, and all the other details will be given from our Instagram and LinkedIn pages. You can follow us on that, and we are sharing our links onto that also. You can also register to our course if you want it. We can share the links on the group. Any questions? I'm going back to the thing. What are the tools? I mean, IDE for writing the code. Question
Yeah,
from.
see, there are many EDA tools like Cadence, Xilium, Quastasim. There are many tools in the industry that can be used, but the access to those tools are quite not possible because the cost of each tool will be running in lakhs. If we talk about Quastasim tool, for single license they might be charging you around 80 lakhs. The tools are quite costly here.
Okay.
Yeah.
What course should I do now to be on LBLSI? I'm from EXTC background.
I didn't get your question, yeah. Can you?
Yeah, Rishikesh, what is EXTC background? Can you please help us on this? Basic time required for mastering the VLSI.
See, if you are good, okay, I would say it is 4 to 5 months. Okay,
Okay.
if you are quite good and intelligent, 4 to 5 months is enough. And if you are like steady and go, I would say optimum time is 6 months. But for everyone, for anyone, the optimum time is 6 months.
Yeah. There's a question. What are the best books? Question from Fatehwasi.
Yeah. See, best book. See, if it is Verilog, Samir Palnitkar is the a book that I could suggest you to read Verilog. Once you are done with Verilog, then you can go to System Verilog, and the author is Chris Spear for System Verilog. That's a very good book. And for UVM, you can refer online. Like there are many websites in online like VLSI Verify, Chip Verify. Many websites are there. You can visit those websites in order to be professional in UVM.
Okay. Sir, any open source tool or cracked version of EDA for physical design? Question from Arabind Sahu.
See, for physical design, I mean, see, I myself have published one research paper, okay, from NIT Delhi. There I had an access, so I was able to do everything, the layout and all those things in a tool, Virtuoso. But what I have seen, I have listened to is there is one cracked version of this EDA tool, Cadence Virtuoso is available. You can simply check online. I mean, maybe you might find it somewhere if you browse. But in even I have seen like there is a cracked version of a tool, Virtuoso available, but it won't give you the full functionality of it. To some extent, you can do. I mean, you can do layout, you can do power analysis, you can do much more things into that, but not the complete thing. Okay.
Yeah. There's a question from YouTube. Currently, VLSI field is going slow. Why? Question from Shanta Kumar.
I think this question is wrong. No,
Okay.
VLSI industry is not going slow. It is, growing quite rapidly. We will discuss on how it is going quite
Yes, yes,
rapidly or why
guys.
it is going.
Every day we
Tomorrow
are
we will discuss
focused.
this.
Yes, yes, we are focused on one respective topic every day. Today we have just spoke about VLSI and its respective. What is the need of VLSI? What is the respective software that we've used in VLSI? All these things are being discussed according to it. Yes, Durga Prasad, we are going to talk about that. Mohan, we will give you the textbook names and all mostly in the next coming sessions. We request all of you to attend the sessions regularly for the next 4 days also. Arabinda is asking you a research paper. Maybe we will share it tomorrow,
Yeah,
Arabinda.
see, if you want my research paper, you just Google my name online. You just search Bijula Pruthwiraj. You will see a lot of IEEE results or whatsoever. You can find it there. Okay.
What should I focus to become a testing engineer? Question from Priyadarshini.
What should you focus on?
To become a testing engineer.
See, here verification, I don't know whether you got it properly or not. Verification and testing are two different entities here. Testing is something that can be done post fabrication. Okay, means it falls under physical design. Okay, if at all you want to be good at that, then you should be good at JTAG. I mean, there are some protocols, and you should be good at DFT. And basically, a single word answer is you should be quite good at analog electronics. Okay, all the concepts of analog, like how a mass transistor works, like what are the different regions of a mass transistor, and how is CMOS made, all its characteristics and all its capacitances, all such things you should be having quite good knowledge onto that. Yeah, anything else?
Does triple people have opportunities to same as ECE people? Question from Sahasra.
Triply, yes.
Okay, most of the
Triply
PhD
and
students
EC
are
are the
starting in
most
Delhi
eligible guys to be into VLSI industry, and even if at all you are
and
holding a
make their
degree in
career in it. Correct.
BSc electronics, also eligible.
Okay. How and from where to start? You can start enroll with us to get the training. Siddhi. Trupti Jagpat says that if I learn only Verilog and basic knowledge of electron, will I still get a job?
Yeah, of course, there is a possibility. See, as a fresher, industry won't expect you to learn everything, right? It is not possible also. UVM is something like, if digital electronics is a small canal and Verilog is like a pond, okay? And system Verilog is a river and UVM is a ocean. Being a fresher, uh, can you be exploring the ocean? Not possible, right? Even the industry guys like us, we know that it is not possible. So we will not be wanting you to be familiar with all those things. Okay, even though you have knowledge on Verilog, it is enough. Well, they will hire you if at all you are good at your critical thinking and analytical ability. They will hire you. Okay, they will hire you even you know you have excellent understanding of your digital electronics. But the thing they require is you should be good at analytical ability. What they will focus on is analytical ability. It is not just something like you can come and do something, some stupid code and you can go. It's not like that. VLSI industry is not like that, and the work is quite huge and salary is also quite huge.
Okay, guys, we have also shared our feedback link. Please give your feedback link. It is important for your certification to get it. We will give the certification to all the 5-day attendees only. I request all of you to please give your valuable feedback. What are the basics in hand to start VLSI? Question from Chedejan Jagan.
Okay, see, you should be starting with the digital electronics. Once you're familiar with that, then go to Verilog. Yeah, once you're done with these two things, it is good. You can start focusing on your system Verilog, but it is quite difficult to understand because SV is something which involves all the dynamic concepts like OOPS concepts. That's where you might be requiring help of a professional.
Okay, there's a question from Khwaja asking, I am 2023 pass out. Can I get a job in VLSI?
Yeah, of course you can get a
Yes,
job.
yes, you can get a job, Khwaja. What will be the initial package for the freshers if they join in VLSI?
See, here there are two things in here. Whether you're joining into a service-based company or a product-based company. See, for example, if you ask me, I myself have worked as an intern at ST Microelectronics. And a basic question to you all is like, if a guy is entering into the assume that the guy is into IT industry, okay, and he got placed somewhere, and what could be the initial salary, in-hand salary he might be taking? Something around 25,000. Okay, being an intern at ST Microelectronics, I was offered 28,000 initially. Later, it increased gradually. That is a different thing. Okay, and these figures are with respect to internship. And if at all you are placed as an intern in Intel, you will be paid 45,000. Okay, and if at all you are placed in Nvidia, you will be getting salary something around 85,000. It's a stipend, not a salary. Imagine if the stipend is something around 85,000, what could be its actual salary? Intel, if at all you are directly placed into Intel, Intel will pay you 22 LPA, guys, for a fresher. Okay, 22 LPA for a fresher.
Is there any software to practice? If yes, how can we use it for free? Guys, maybe that we can discuss in the next coming sessions, Likita, according to your question. We have just today discussed about the introduction of the VLSI and what are the segments of VLSI. I request all of you to please give your valuable feedback. What is meant by C-based VLSI? Question from Vinayak.
See, there is no, it is not like it is a C-based VLSI. See, C language can be used in VLSI. Okay, for example, if at all you are asked to work at SOC level, SOC means that it means that it is system on chip. So if at all you are working at SOC level is quite complex to verify. So by using your traditional system Verilog or UVM, you cannot do that. So that is where some language like C comes in handy. So you will be writing some test cases in C language, and you will be firing those test cases by using some methodology known as UVM. Okay, thereby the verification becomes kind of simple if you use C. Okay, if you use C language.
There's a question from YouTube from Sai Lakshmi Rao. Apart from digital electronics and Verilog HDR, do we need to learn more for design verification engineer as a fresher?
Yeah, you should be familiar with system Verilog as well as UVM also.
Okay. There's a guy named Siddharth from YouTube. So I had done a done PLC course. Is it similar to VLSI? Not completely.
No, it
Siddharth?
is something with respect to embedded systems, right?
Correct. Yes, yes. There's a question from Harshit sir. I did not learn system Verilog. Is it necessary for future placement offers? Yes, if you want to pursue VLSI career, it is. That is what we are trying to tell you on the session. There's a guy from MK Tech Solutions. I did BSc Electronics and MCA. Am I able to or I'm eligible for VLSI industry?
Yes,
That's the
you are.
question.
Yes, you are.
Okay. Can you
Even
tell
if you
us?
hold a diploma in electronics, then also you are eligible. I have seen a guy who just did diploma and he got placed.
Okay. There's a question from Shantakumar. In India, is there any fab units?
No.
Okay, we don't
See,
have.
that is actually the need of the hour for India. If at all we have any fab in India, maybe in next 10 years, we could reach China's economy. That is the potential VLS industry is having. Okay, it's huge. In fact, the fab is the reason why China wants to take over Taiwan, because Taiwan is having TSMC, Taiwan Semiconductors Manufacturing.
Okay, there's a question from Vinod Kumar from YouTube. He's asking, I'm already getting job in core sector to get job in Alstom. Do we get job in Alstom if we learn VLSI is the question, I guess.
Do we get
Right?
job in what?
Alstom. Alstom is a company.
Okay.
Okay.
It
Uh,
depends, yeah. It depends upon your skill and many
yes,
other
yes,
things,
yes.
right?
Even though you have your different experiences, MK Tech Solutions or Lazy Gamer, who are speaking here, you have your backlogs, you should clear your backlogs to get a job, guys. That is for sure. And people who have experience in different segments, as in battery chargers or any other segment, if you want to learn VLSI, maybe we can help you to get through into a job which is of your interest. That's the reason we are here, guys. There are people who are asking, can we get any internships if we are pursuing in VLSI companies?
Yeah, you can get internships.
Yes.
It is possible. In
Uh,
fact, you should be, going through all the LinkedIn profiles and following people, and you apply, you will get it.
right. Guys, it's a paid course and the course details will be shared from our teammates, and I'm sharing our numbers on the chat box. You can have a look into our course duration. Do we have any CGPA cutoff for VLSI job? Not all companies ask for cutoffs, Hitesh. Some of the companies also look at your interview performance considering your requirement. BE graduate in initial, yes, we have discussed about this, Sushant. As an intern, what could be the salaries is a question from Sushant Prithvi.
Yeah, I have told if at all you are placed into Intel as
Yes,
an
we
intern,
have
you will get
answered that.
45,000. If it is Nvidia, it will be 85. If it is Qualcomm, they will pay you 55,000.
Yeah, it depends on the company, Sushant, and
And not just the company, it also depends on where you are from and how well you performed in the interview.
yes, we have put our details on the chat box, guys. You can register to the link, and people who didn't give your feedback yet can give your feedback for the next day session and your certification also. People on YouTube, please do give your feedback on the link. And there's a question from Mrunali on YouTube. Python language is required. Is it
Yes,
required?
yes. I mean, scripting language is always an added advantage. Initially, when I entered into ST Microelectronics as an intern, the first task that they gave me is to do some kind of automation by using the scripting language. Yeah,
Very
we will be discussing these things in our coming sessions.
Yes, yes, thank you. Thanks, Pranali, for the question. There's a question from Nikhil Kumar Reddy. Is there any online class? Yes, guys. HIW session will be for both online and offline, which is starting on Jan 20th, 2025. You can register our course, get to know the details more from our team, and all the details are being posted on the group. Which link is not found? Akhila? Link is not working. Could you please copy the respective chat into your normal thing and then see? It'll work.
Yeah, I have seen the link is not working.
Oh, is it? Just a moment.
The link that you have shared in YouTube.
Just a moment.
It says dynamic link not found.
Yeah, I'm just sharing the link, guys. Maybe the respective message after that continuing is giving a problem. Can you please check with this now, guys? Ma'am, will you be still help after 8th semester to get placed after clearing backlogs? Yes, you take the time to clear it and come back to us. We would like to help us, and that's how we do it for our electrical courses from all 15 years, guys. For VLSI, need core background or anyone can join? A question from Omkar. Can anybody join VLSI or it's only the core background, guys?
See, basically,
You need
so
some
so
knowledge
far
on
on what I have seen,
academics.
electrical electronics guys are eligible, and here and there, I think once I have seen a CS guy in semiconductor industry. It is quite unusual actually, but electrical electronics, they are given 100% flexibility. They are 100% eligible.
Okay. So guys, it's purely on your interest and how hard work you're going to work on that if you're from another department. Yes, what will be the work need to do in VLSI? Question from Shiv.
What will be the work? That's what we have discussed so far, right?
Yeah, she was joined late, I feel.
uh,
Shiv, you have the recording of the whole session on YouTube. You can actually look into it and come back to us tomorrow to put your questions again. Shubham will be answering the course fee personally to one-on-one. Our team will come back to you regarding the course fee. Please reach out to us, and I request all of you to please give your feedback. You will get a call. If you have a query regarding the fees, you can put it in the comment session. We'll come back to you on that also. Sriharsha, we have answered this question. Yes, I have a question here. Will the classes be starting from tomorrow? No, Kavya. Classes will be starting from January 2025, the next year. So you can enroll to the course and join us. Guys, I request all of you to give your feedback. Please give your feedback. Prithvi, can you please confirm if the link is working on the YouTube?
just give me a moment, yeah.
There's a question from Nishant.
Yes, it's working. Guess it's a feedback form, right?
Correct. Yes, there's a question from Nishant. So, do we need to learn Zilix Viado also?
See, Vivado is a tool, yeah, okay. That's just a tool. And on the tool, you will be writing a code. So you need not to learn Vivado. I mean, in order to work on that tool, you need to learn a language that is HDL. Either it could be VHDL, Verilog, System Verilog, or whatsoever. Vivado is a tool, okay. You should have a knowledge of Vivado also.
Yes. I have a question from Trupti Jagpat saying after joining the course, will we get enough to get placed? Yes, we will be training you for 6 months, and post 6 months, we will try to start placing you according to your skill set and all. And placement assistance will be from HIW, guys. Is TCL scripting important?
Yeah, see,
Question from
basically,
Yatesh.
basically, there are many kinds of scriptings like, Tickle, Perl, Python. So it is good to have any one of the scripting language. If you specifically talk about Tickle, if it are you want to be a backend guy, then Tickle is quite important for you than the front end guy.
Guys, we do provide placement assistance. Okay, if you get trained in HRW. Harshit, the link is working and we have got a confirmation from so many others. Please try once again on the feedback link. So I think we are almost done, Prithvi, for the day. Most of them have asked their questions and we'll come back tomorrow. Is Linux better? The last question for today. Is Linux better for VLSI engineers?
See, what I mean, this question is like, it could be more. I feel it is not fully framed. Okay, see, what do you mean by is Linux enough? Like, you mean to ask me with respect to the device drivers of Linux? Is that the question?
Question was from Aravind Sahu. Sahu, you are there? Yes, the training course is offline and online, and the offline session would be in Hyderabad at our institute location. You can search for HIW and online, you can get our thing. Yes, Arvinda is saying that it's a scripting language in Linux is better or not.
See, scripting language in Linux is better. Okay, see, if at all you're able to do that there, you will be able to do it here also. That's not a problem, yeah.
Okay, there's a question from Jagan asking, is there any similarity between embedded and VLSI? There's a lot of this.
There are many differences and many similarities.
Yes, yes. So, guys, we will try and understand how VLSI is different also in coming sessions once you look into it. Yeah, so yeah, I'm in third year, so which thing should I do to get a job in VLSI? Shiv, yes, you first finish your curriculum and then come back to us in fourth year. That would be better if I feel it. Currently, you need your academics from your college. Is Cadence and Synopsys software enough for our ECE students? Question from Vijendra.
See, basically, Cadence and Synapses are company names. They are not tools. Okay, Cadence provides something known as Xilium. Okay, so that tool is found nowhere to be seen unless you are onto a project. Okay, they are quite important. And if at all you want to get its license, it's quite not possible because I have told you, it will be around 80 lakhs per single license.
Okay, Prithvi, I think we are done for today.
Mhm.
Guys, I request all of you to please give your feedback form, on the given feedback form. Thank you for your queries. You can put your rest of queries on the feedback. We'll reach to Prithvi on this and he'll answer the queries tomorrow in tomorrow's session. I request all of you to please give your. Thank you so
even
much
though
for your response, guys. Sorry, Prithvi. You
yeah,
can
it's okay. Even though you're in third year, you can join. Yeah, that's not an issue.
Yes, yes, you can join it. But you'll be taken as an intern in the companies if you're into third year.
Yeah, in
Guys,
fact,
I have a request here. Like, please follow us in LinkedIn and Insta for further updates. So you'll get time-based updates in the LinkedIn and Insta.
Yes,
So that is
done in
one
our
request.
collaboration. Yes, you can join us on Facebook, Insta, as well as LinkedIn. We'll share our links sooner.
I
And
already shared the
some
LinkedIn
of the links of
link in the
LinkedIn and
chat
all of the
box.
features, you can get back to us. Thank
Thank
you.
you.
Thank you, guys.
yeah,
Thank
thanks
you. Please
everyone.
give your
Thank you
feedback,
so much.
everybody. Anybody missed out, you can give the feedback, both the YouTube as well as the respective Zoom students. And thank you for your response and presence on the session. Thank you, Prithvi, for your valuable time. See you
Yeah,
tomorrow, guys, all of you. Please be on time. Thank you so much. Have a
yeah.
good day. Good night.
Thanks, bye bye. Thanks everyone. Good night.